Welcome. In this lesson, we are basically going to help you understand the difference between linear and nonlinear. I don't necessarily need you to know so much about the actual equations of nonlinear, just what you'll see in a nonlinear equation versus what you see in a linear equation. Graphically, it's very simple. Linear is just a straight line. As long as you never see it bending or turning or curving, no corners or bends, it's linear. But a linear equation can be written in many different forms. All of these on this left side are linear equations, but if you'll notice, there's just always a y and an x with some number next to them, and it can be fractions that are next to the y and the x, but we're multiplying the x and the y by those fractions. We could have a fraction where x is in the numerator, or we could have just y equals 5, which is a horizontal line, but these are all linear. Things that you'll see in a nonlinear equation are exponents. Any type of exponent. So y equals x plus 3 raised to the 4th power. That would be nonlinear. Anytime you have an exponent, it's nonlinear. Square roots of variables are nonlinear. Anytime you see a variable that is square rooted. Anytime you see the variable in the denominator, it's nonlinear. This is the absolute value. It's a V-shaped. It's nonlinear. Anytime you see a variables multiplied together, both the x and the y times each other would be a nonlinear. So all these are nonlinear. Again, I don't expect you to actually have them all memorized, just kind of get familiar with them. So when you go through these, you can quickly identify which ones are linear and nonlinear. And obviously that's not straight, so it's nonlinear. The graph ones I know will be very easy and quick for you. You'll be able to fly through the graphical ones because it's obviously straight or it's not. Oh, by the way, linear doesn't necessarily mean it has to be a solid line. As long as they follow a linear path, a straight path, it's linear. So as long as it follows that, see, now this is a curving path. Even though it's a bunch of dots, that's nonlinear. Nonlinear. And I'm hoping to get to some of the equations really quickly. I guess I could jump ahead. Oh, here we go. Now you see a square root. Remember, square roots are nonlinear. This is linear. Y equals mx plus b. Ooh, I see an exponent, x squared. That's nonlinear. Y equals mx plus b. That's linear. Y equals x. That's linear. Ooh, I have a variable that's an exponent. Again, anytime you see exponents, ooh, and you know, especially if it's the variable, it's the exponent. That's nonlinear. I didn't put that one over here. So I should have put that one over here as well. If you have 2 raised to the x so the variable is an exponent, that would be nonlinear. That's linear. It's like this one down here, the y equals 5. It's just a horizontal line at -6/7. Ooh, I see this huge exponent, nonlinear. Division by a variable. I can never have the variable be a denominator. So they can't divide by x. That's nonlinear. It's all right to have x on the top of a fraction, though. That's perfectly fine. X is all right on top. It's all right on top. It just cannot be on bottom of the fraction. Again, exponent, nonlinear. Like that's a horizontal line. That's linear. Square root, nonlinear. It's all right to have the variable on top of a fraction. That's just y equals mx plus b. It's all right to have fractions times by, ooh, exponent, nonlinear. Ooh, exponent, that's the variable. That's nonlinear, not linear. That's nonlinear. That's a horizontal line, so that's linear. Division by an x, variables in the denominator, nonlinear. If you have any questions, please bring them to class.